In this video, I will be talking about the evolution of machining practices, as well as the cultural ramifications brought on by increased manufacturing capabilities. Lathes, turning mills, and gear cutters had already been put to use from the late 1800s for industries like bicycle, sewing machines, and typewriters. America began entering this age of mass production after the Industrial Revolution, and metalworking became a crucial focus. By the 1920s, assembly lines such as the ones created by the Ford Motor Company put these machines to use and made the widespread use of complex products a possibility. The volume and speed of manufacturing, however, was still dependent on the machine's capabilities. Automobiles, planes, and telephones began to demand increasingly more complex parts. Fast forward 30 years, and after 2 world wars, the demand for speed and intricacy in manufacturing surpassed human capabilities. In 1949, John Parsons created the first computer numerical controlled device. This paved the way in automation. Manual operation of these machines was no longer necessary, but rather a set of inputs and a press of a button, so to speak. Much of the labor force involved with part drafting, blueprints, and operation became obsolete. Processes that involved intricate measurement and skilled precision were reduced to a set of numerical inputs. This caused an alienation of labor. Rather than controlling the machines, people only needed to do the initial setup. This diminished the aspects of creativity, personalization, and individuality. The more specialized these machines became, the less work needed to be done by the operator. Machine operators became less of a unique skill set and more of a blue-collar job. In contrast, mechanization of machining processes also brought with it new specialized jobs. These required increased schooling and education, with an increased emphasis on math, physics, and science. This automation and level of production created a demand for power technology, processing technology, material handling, material cutting, and control design. Widespread machine use and capability made what some people refer to as the Second Industrial Revolution possible. This Second Industrial Revolution was marked in history by a boom in electricity and mass production. Just like engineering became a rising profession in the First Industrial Revolution, with the manufacturing of steam locomotives and increasing use of electricity, this second revolution coincides with a spike in engineering and other technical careers. Subdivisions in engineering were required to branch out into areas like aeronautics, telecommunications, and chemicals. The IBM 602 machine, as discussed before, was the first numerically controlled device. It was a major stepping stone making way for the vast new field of programming. Once data could be stored within the computer's memory, programs can be shared and easily duplicated or dispersed. Programming would eventually be used in countless manufacturing processes and used to impact our everyday lives. The IBM machine's applications and programming technology was quickly accelerated by its incorporation into computer automated manufacturing. The ability to make recreatable identical parts became crucial. In the ongoing trend of increasing efficiency, standardization within American business became an ongoing goal. CNC machines brought standardization in coding language called G-code. It also created more industrial standards in areas such as tolerancing, part quality, and materials used. This promoted fast and efficient communication between manufacturers and businesses, not only within our nation, but across seas as well. Tremendous growth in productivity, transportation networks, and industrial production lowered the price of almost all goods. The economic backlash of such growth and reduced costs led to some businesses to fail, along with periods of economic depression. The working population in agriculture fell during this rapid industrialization. Urbanization increased and employment rates were higher within cities involved with mass manufacturing. It is safe to say that machining capabilities have allowed us the standard of living we are accustomed to today.